This is X5 pass exam, questions 1 to 4, basically the whole thing. And all of the questions are about simultaneous move games, about solving for the Nash equilibrium. So the first one is the simplest one, where we have two players and two actions, so you can actually draw the game. If you have more players, then you cannot draw the game as a matrix. So here we have the matrix, but there is a problem with the matrix, is it does not contain all the information. So the first thing is just fix the matrix so that it contains all the information. The matrix only include the bonus part, so when you consider a game matrix, it should measure like the combination of all the effects of the actions. So now we're just considering the bonus, so we also need to add up the value of slacking. So if person A slacks, then person A not only get the bonus, person A should get the 6 from slacking as well, so that's 14, and similarly that's 16. And we should do the same thing for the other player. So B, if I slack, I will get 16 here, 14 here, plus 6, and then I should get 16 here. So now, the updated table is actually what we call the game matrix. So knowing this, we can just find the condition when these two actions are best responses. And what I mean by best response is, given the other player is playing work hard, given the other player is working hard, I would prefer to work hard, so then to slack, which means I would prefer X to 14, and that's for A, and the same thing actually happens for B. So for B, the condition is exactly the same. So in both cases, we need X larger than or equal to 14. If the values turns out to be different, then we just take the larger number. Here, it's asking for the smallest value of X such that it works, so the answer is 14 in this case. And next, we already upgraded to having 266 people. So that's a large game. We cannot draw the game. So we will just directly figure out what this number is, and so on. So let's start with the Nash equilibrium. So in the Nash equilibrium, let's say there are n people driving the direct way. So there are two methods to get to work. And one is taking the long way, and the other one is taking the short way. But the short way really depends on how crowded it is. So there are how many people? N players, say in equilibrium, that takes the short path, and there are 266 minus n people taking the long way. Now, the key thing here is just stating what the Nash equilibrium means. So for any of these players, any of these 266 minus n players, in order for them to pick L must be better than D for these players. And for the other players, for any one of these players, we actually need D larger than or equal to L. Then one thing you might want to just do would be just set them equal and solve. That's not the way to do this. And you'll see why. So first, let's start with the condition for these people. They are taking a long way. So they are taking a long way, and it requires 1 hour. And I prefer a shorter time, so of course I will flip the sign. So one needs to be, so if I take the long way, it should take less time than if I switch to the short way. So that's the idea, or the direct way here. If I switch, according to the formula, it says n over c. But the problem here is if I switch, I'm adding one person. So think about if I'm playing L and I switch to D, what will happen is n is not n anymore, it's n plus 1. So that condition is actually wrong. when I switch, I will actually add 1 to the other side. So that's the condition here. And it's already not setting them equal. Okay, let's see the other one. Let's use the thinner pen. For these people, these M players who are picking D should be better than L. So, which means D, currently there are M players. I'm one of them, so I'm not going to add 1 or subtract 1 because I'm staying at D. It needs to be less than or equal to 1. If I switch to L, say switch to L, it doesn't really affect the amount of time I need, so it's still 1. So that 1 comes from 266 minus n plus 1 people, but it doesn't matter, it's still 1. It's just, it doesn't change. If this is also a function of n, then we do need to modify the function, but here we don't. So now we have the condition, and it's just n over c is 19, is less than or equal to 1, which in turn is less than or equal to n plus 1 over c. So you can solve this. You can solve this for n will be in a range, and there will be an integer in the range. And I think the simplest solution, it turns out, for this question is actually just n is 19 would work. But in general, what you should do is solve this thing, and then you will get a range for n. Say n maybe between 19 and 20. Then say both of the answers will be correct. Or actually here it should be between 18 and 19. So 18 should also be a solution. Okay, so let's make this even more complicated by having a different function on both sides. So now we don't have the constant 1, we just replace it by a different expression of n. So the way to solve this is exactly the same. Let's try to do it. So let's use the same color. We have a group of people who are using the filter, and there's a group of people who are polluting the environment. How many of them are there? So there are n of these people, and there are 19 minus n of these people. So again, we're saying if I pick this, I should prefer this. I should prefer F than R. So that are these people who choose to install the filter. So again, these are costs, so people want to minimize the cost. So again, we need to flip the sign and stuff, but yeah, the only thing is just to flip the sign. If I choose to install the filter, I incur a cost of 10 times n plus 60. So that's okay, and it should be less than or equal to, again, since we're minimizing, we need to flip the sign. So it should be less than or equal to if I switch. If I switch, you may think again it's just 15n, then well, then just set them equal and solve for n. That's not the case again. So if I switch, it means originally I am playing F, and now if I switch to R, then what I'm doing is I'm adding 1 to the group of people who are polluting the river. So this now becomes n plus 1. So again, it's the same logic as the highway question. If I switch, if I'm one of these people, these filter people, if I switch to R, then I'm actually adding 1 to their total count. So that's why we need the plus 1 here. And so, sorry. And of course, if I'm one of these people, I'm going to say I prefer R to F. So what would be the answer? Let's see. If I play R, I'll just get 15n. If I switch, I will get, it means I'm going to switch from R to F, which means there will be n minus 1 of us choosing R. So it will be 10 n minus 1 plus 60. So again, these two are the most important conditions. If I switch, I need to either add 1 to my group, or to the other group, or I will subtract 1 from my group. So if you have these two expressions, you can combine them, and again, you can solve for n. N should be between two numbers, and likely they're going to be there will only be one single integer in between these two. So I think in general, these two numbers may not be integers, but there will be an integer in between. So whatever the integer is, just put it in here. So I'm not going to solve the algebra here. Right? Okay, so the last one is the vaccination question. So it's about herd immunity. It's kind of not a good time to talk about kind of convincing people not to take the vaccine or take the vaccine, but well, we can still solve the game. So the game basically says if you take the vaccine, there is a cost and there is a probability of getting the virus, which will cause some which will incur some cost, and also there is a cost to just taking the vaccine. So you can think about maybe the actual cost of getting the vaccine, which may be free now, but some other costs, like there are side effects of the vaccine and so on. So they are summarized in this cost parameter, and the alpha and beta parameter, basically they measure if I take the vaccine, and if I don't take the vaccine, what's the likelihood that I will get the virus from someone else in the population? So these are basically my payoff, and we will solve this question the same way as before. So let's see, there are 190 players now, and some of them are vaccinated, so V, V, and V, and other ones are not vaccinated. So let's say N, N, and N. There are N of these people, and there are 190 minus N of these people. Yep. So we're going to analyze this exactly the same way as before. If I'm one of these unvaccinated people, then what it means is I should prefer not getting the vaccine over getting the vaccine. So in particular, it means if I don't get the vaccine, then what's the payoff? So the payoff is minus alpha times N over N. And N is 190. I'm not going to write like substituting numbers here. And if I take the vaccine, then again, the key point is if I take the vaccine, I'm going to switch from N to V, which means the total number of unvaccinated people will decrease by 1 because I switched. So in that case, I'm going to get minus C minus beta N minus 1 over N. Okay, so that's the first part. And the second part is if I'm one of these vaccinated people, I should not switch. So that, again, that's the definition of Nash equilibrium. If I choose something, I should not want to switch to the other side. So I should not want to switch to N. And for these people, for these 190 minus N people, I should prefer V to N. Okay, so if I actually take the vaccine, then I'll get minus C minus B N. And if I switch, then it means there will be one more unvaccinated person. Again, I'm one of the vaccinated people. If I switch, there will be one more unvaccinated person. So it will be N plus 1 and then over N. So now we have these two conditions, and it may be slightly harder to solve for n, but then again we can get n between two numbers. So if you substituting the alpha beta stuff, so alpha beta and c, then you basically have all the information here. You can simplify this, and for one of them you'll get n less than or equal to something, the other one you'll get n larger than or equal to something, and very likely that these two numbers will not be integers. If they're not integers, there's one unique number in between. So some of you would think maybe I can just set them equal without the +1 and -1 thing and solve. The problem is you don't know whether you want to round up or round down, because there's only one answer that's correct, that's in the middle. So don't set them equal and try to guess whether you want to round up or round down. The best way to solve this is actually have two inequalities, combine them so that you know the upper bound and the lower bound, and then there will be one single integer that's in between.